in my I discussed about different control strategies. Okay, so in my last class, I just keep more trust on the configurations. Okay, so what type of electrifications are required in the traction track? Okay, what are the different name of the substations? Everything I was discussed in my last class. Then control strategies for the traction motors. Okay, so basic traction motor. Okay, so for a DC motor, then in AC motor, I was discussed about. I think all of you are aware about it. What are the most important controlling strategies? Okay, so what are the most important controlling strategies for induction motor drives? Okay, so most of the thing you know about your machine classes, so I'm not going to repeat all those things again. I just specify the name of the controlling method. Okay, so you know that from the slide it is you can see, I think so. So it is observed that most important controlling strategies, okay, are the rheostatic control, pole changing control, cascade control, combination of cascading and the pole changing control. That all are the very old and the conventional control method. But right now, scalar controls and vector controls means in if that electric drives was already included in your syllabus and you have already attended all those class on the electric drive. So I know that as it is the AC motor, and right now that power electronics converters are the play the very important roles for the different controlling strategies for DC machines as well as the AC machines. Okay, so the scalar and vector controls you can easily use on it, and by using that control you can easily control the flux, everything. So that flux should not be reached to the saturation conditions. Okay, it should be the below saturation level. If it is maintaining the it reaches to the saturation, then there is a problem of saturation nonlinearity. Okay, so you know that flux is directly related to the hysteresis, everything. Okay, that means magnetics nature of the system. So that's why it is most important. That's why it is most important for sophisticated control. That means right now that all the most of the control of the motor, you know that microcontroller and the microprocessor based controlling methods are already there, and everything, and the inter drives will be installed. All the drives will be installed in the locomotive. Okay, so you can easily control and sophisticate control without having any non-linearities. Okay, so all the time you should maintain that V by L. Okay, so the flux will be constant. Okay, so it should not be very high and very low. So it should be selected in the moderate value within the linear zone of operations. Otherwise the system faces different kinds of difficulties. Okay, so here we can see the different conventional control policies for the induction motor. Okay, so I told in my last class, so in traction, in initial days, that DC series motor are used, right now. Right now the induction motors are also being using in the traction. Okay, so we should very much focus on it. Okay, so first we discussed about the DC machine control, then induction machine control. Now the another important issue is your braking. Okay, so why it is important? In my last class I discussed about the different types of braking and necessary remains the importance of the braking. Okay, so in types of braking means what dynamic braking is important, or something plugging or regenerative braking. Braking means reverse operation of your motor. Okay, so reverse braking means again it's the operation of the motor. So motoring operation and reverse means reverse motoring operations. Okay, means in a single word it is braking operation. Okay, in motoring operation, you can understand that you can understand the characteristics of the motor. But in braking operations, normally we are giving more thrust on regenerative braking for mainline for the mainline loco means mainline tractive effort of the locomotives. Okay, so in that case, we are giving the more thrust on regenerative braking. Regenerative braking means you are make your system means you are making your system passes through the regeneration. Okay, so what happened? That additional energy will be feedback. Okay, to the contact and the contact wire of your means overhead wire, and that additional energy will be taken by the other locomotive that is already in line with this track. Okay, so if say regeneration of braking means huge energy will be feedback to the system. So in the system have sufficient load, system should have the sufficient load to collect, okay, to collect all those additional energy. Otherwise what will be the problem of the insulation breakdown. Okay, because suddenly the voltage level of that means overhead line will be high. Okay, so suddenly the voltage level will be enhanced or increased, so that may cause for insulation breakdown in the side by substations, as well as overhead insulator. Okay, so that energy should be taken by the other locomotive. Okay, so that is important one, that it is regenerative braking. Another braking is your another braking. I am talking about all those braking in the electrical point of view, electrical braking. Okay, so first we should go for that electrical braking. Basically we are using the electrical motors, no, electric motors, so we should the main thrust is electrical braking. So in electrical braking, that energy loss will be comparatively less. Okay, with your mechanical over your mechanical braking. Okay, so next one is your plugging. Plugging means reverse braking, means reverse motoring. So motor is going forward directions. If you want, so it can also go to the backward direction. But how? So we should follow that plugging pattern. Okay, so by using that plugging, so a motor can come to, that means locomotive can come to the reverse directions. Okay, then rheostatic braking. In my last class I will just show you that diagram, that rheostat resistor grid. Okay, means armature will be directly connected with that additional resistance. Okay, there you can see different bypassing switch. Okay, if all the bypassing switch is on, sorry, off, then all the energy will be passes through that rheostat grid. Okay, then what happens, that additional energy will be dissipated by this rheostatic field. Okay, so that is called dynamic braking. So as per the control, speed control of your motor, okay, you can go for means one by one connecting of your breaker. Okay, that circuit that you know the switches are there, so one by one switches you can turn on to diversify that additional resistance path. Okay, so that you can go for that rheostatic braking, that also known as dynamic braking. Okay, so additional energy will be dissipated at the form of heat. So rheostatic braking also very energy consuming. Okay, so next one is your mechanical braking. So first three I have discussed on that electrical braking, then next one is the mechanical braking. In mechanical braking, I think all of you heard about that, if the train is running, then suddenly if the chain, okay, you know that emergency purpose, you know that in chain is there inside of that bogie, okay, with the regular interval. If you pull that chain means in vacuum, okay, normally compressed air brake and vacuum brake, we are using the vacuum brake. Okay, means there is no air, okay, in the brake of the train, the locomotive. So if you pull out the chain means some air will be entered to your system, vacuum system, braking system, so that may cause for suddenly locking of the train wheel. Okay, and train will be stop. Okay, so that's why unnecessarily nobody should pull that chain. Okay, otherwise what happen, huge energy will be lost. Okay, because of the mechanical braking, you know that corrosive effect will be there. The sound due to the corrosion, basically that pole shoes you can see from that diagram. Okay, so it is your wheel. Okay, wheel is there. Okay, and you are giving that brake shoes are also be there. Okay, brake shoes are there. You can say the different types of braking. So grip, that holding grip is there for the rail. It is your rail, and that wheel is coming or going upper side of that rail. Okay, that is holding track is there. Okay, so that clamp directly that is called that adhesion control, na? So directly hold that wheel. Okay, if it is holding the wheel, so automatically train will be stop. So that's why unnecessary stopping the train is a criminal offense. Okay, so due to that huge energy is lost due to the mechanical braking. Then that compressed air brake and magnetic track brake. So all are related to each other. So compressed air brake means air compressor will be there, that air will be suction. So suction pump will be there that can extract all the air from your braking track and exert means expel to the atmosphere and make the system is air free. Okay, so that is your compressed air brake. Next, on that vacuum brake, due to using that compressed air brake, so then reverse operations in that vacuum brake. Okay, so we have make the tube in vacuum, so suddenly any air will become, so it will be off. Okay, then magnetic track brake. So after that you are using magnetic track brake. So if you give that power supply, so it will be the electromagnets that it will be like brake shoe. Okay, holding your wheel hold. Normally it is you can see, you can observe minutely the below portions of your locomotive and the train bogies when you are traveling here means one place to another place. So you can see basically most of the important features will be connected below of that train means below of your locomotive and upper side of the locomotive. But upper side nothing big things are there, only pinto and that electrifications means how to power supply coming from pantograph to air circuit breaker means pantograph to circuit breaker. Then one cable is there, that cable is connected to the auto transformer of that locomotive. Okay, then auto transformer having some of the sorry the transformer having different coils. Okay, number of different coils are there and it will be connected to the system as per that winding. So different applications are there for the traction application and the auxiliary power applications. Okay, and the below of your body train body, you know there will be battery bank, smoothing reactor. Okay, battery charging stations. Okay, then drives that you know you are using that huge, you are using that induction motor. So who will control that motor? So induction motor drive also be there, means power electronics component based induction motor drive. Okay, and that microprocessor everything will be there in the loco cabin. Okay, that those are the drivers. So driver are experts in basically the train drivers are all are the engineer, maybe mechanical engineer and the electrical engineer. Okay, so they all are the very expert about these operations. And you if you enter to the any of the coach means loco cabin means where the driver will sit, so you can see lot of gauge. Okay, lot of gauge, relay point. Okay, relay point, you know that lot of protections you need to be used. Okay, so each and every, so charging current, everything, driving voltage, everything will be and the rpm. Most important thing is that rpm, tap changer value, everything will be there. So that person, the driver should be very technically, that person should be very technically sound and have well knowledge on it. So without experience nobody can drive it. Okay, so lots of things are there, basically ht relay, lt relay, and their connectors means reading monitoring system. So that's why multiple person will be there at the time of driving of the train. But in case of locomotive means only urban suburban urban suburban communications of railway. So you can see only one driver is there. Basically in that case it is if the travel distance is less, so that protective measure and the other features of the component is quite less compared to your long line or main line means tractions, okay, railway communication. So that's why one person is well enough, and you know that one person is there, he is sitting at the guard, okay, you know that railway guard, the purpose of the guard is to maintaining that signal system, okay. So if you give the signal, only the actually guard is the personnel, he had the whole control of that chain. So without his instruction, without his and her instruction, so that locomotive cannot move, okay. So he is the main supervising authority of this one. So if you see, there is some sensor when that motor coach just passes through the signal line, okay. You know that signal system right now, that automated signals are there, okay. So and the motor coach means that front motor coach, it passes through the signal line, so automatically it will be red, okay. So if the train is reaching with the certain distance from that signal tower, after that only the signal will be green, okay. If means if other person give the signal, only it will be green, okay. Not like that train will maintaining the, definitely the train should maintain the keep safe distance, okay. So that distance also been maintained by the signal means signal room, okay. So in the station master normally controlling all those things, the signal room functions. A lot of technical issues are there, as well as that driver. So those are the train drivers are there, okay. So they need to know different uh, when that isolator will be on, okay, when the isolator should be off, everything, every instruction will be given to him, and in the time of running of the train, so that instruction will be written in the poles of that railway track, okay, and the upper side of the railway track. So when they are driving the train, so they need to be very cautious about all those things, okay. So what is the instruction, what is the speed limit, everything will be written there, okay. So all the time they should monitor on it, and the maintain the instruction, okay, keep instruction, take the instruction from that prerequisite, okay, given requisite, okay. So now most important factors are there for the two factors for determining the ability of the locomotive to the uh, uh, locomotive to the means tractive effort of the locomotive. So most important features is the start, accelerate, and obtain the top speed, okay. So starting of the train, okay. So basically that motor should be overcome the friction, okay. The friction will be there, okay. That motor should overcome the friction, then it will start, okay. Start and accelerate. So then accelerate means gradually it will be the speed of the train locomotive will be increased, okay. Then it will be reach the top speed. Then after that the coasting is there, and then retardation will be there. So I will discuss thoroughly in this part in the speed torque characteristics, okay, at the end of this session. So in end of this session means after completion of this slide, so then one session will be there in speed torque characteristics. I will discuss on it in my class, okay. So tractive effort, so that is normally known as the tractive effort, and the ability of the overcome the resistance, okay. What type of resistance? You know that starting, grade, wind, curve, rolling. So train resistance means friction, also very important issue, okay. So chain resistance you mentioned, it is mentioned resistance of the chain means friction, means static friction, also the important. So starting means it is static friction, then grade, wind, curve, rolling. So all those things are important for the tractive effort, okay. So it is a tractive effort. So tractive force equal to weight of the drivers and coefficient of addition, okay. So addition means, you know, the tractive effort means important for movement of the train. So which are the most important features, okay. What is the rating of that horsepower rating of the motor, okay, means traction motor, normally it is 1500 to 5000 HP, okay. Who are the main leading companies to designing that traction motors in India? Normally Rail is designing that motor and supply to the Indian Railways. Okay, there are other motors are there. Hitachi motor is there. Maybe means Western House means that motors are coming from exported from the fine. Hitachi motor means that is Japan, I think so. So but normally in current scenario, most of the motors and drives, everything will be supplied by the rail. Okay, and that locomotives is designed and driven by the rail. Okay, rate of doing work. So how much time it will be work. Okay, so duty is important. Continuous duty or intermittent duty or short term duty. So I normally it is designed for the continuous duty. Basically, chain means locomotive should be designed for running conditions. Okay, all the time it should be work. Okay, so that is designed for the duty. Based on the duty, the insulations. Okay, the insulations and other parameters. So different grading of the insulations are available. Okay, so A2 up to F type of insulations, and based on the duty, so you have to select the insulation. Okay, then horsepower available to the whole. So different that important features. Okay, you need to keep in your focus. Okay, for your locomotive means starting and controlling the locomotive. Okay, so here that addition material grip. Addition means what happened, the grip rail without the slipping. Okay, so that's why that grippings are there. So that the two grippings are there, so that can prevent the slipping of the wheel from the track. That is your track, so it can prevent the slipping of the wheel. Okay, and depends on the weather, real conditions. What do you mean by the depends on the weather means, that sander. Okay, so sometimes in a locomotive that sanders are there. Sander means what? So the tractive effort, all the time the tractive effort is not like that it is in straight, means not straight line, it is in plain land. Okay, sometimes they need to be the train need to be travel in the hilly area. Okay, if that Himalayan railways, or if those are going with the train means traveling to Arunachal. Okay, Arunachal or Tripura means Agartala through the train. Okay, so the train need to travel, okay, to the high altitude, and the train need to travel in the side areas of that hill. Okay, so what happened in that case, that there is a provisions of the slipping of that wheel. Okay, so that's why one relay is there. Okay, so all the time slipping means definitely there is a changing of the current level. Okay, so one relay is there that is enabled. Okay, the sander block means the sands are that means here the track is there, the sand will be emitting to the track. Okay, from the locomotive. Okay, that sand will be already, we feel sand will be there. Okay, when it will be hilly area, so sand will be falling to the track. Okay, to prevent the slipping. Okay, to prevent the slipping of the train. So that also be automatically controlled by the weather. Okay, another thing is there, if train is traveling, so if there is a snow. Okay, if there is a snow in the track, then again there is a problem of a slipping. Basically snow is there means mu value is less. Okay, what is mu, that means sorry, that what is called the mu value is sorry friction. Okay, so mu value is less. Okay, due to the less mu value, what happened, there is another chances of the sleeping effect. So again the sander will be there. Okay, that can enable and make the system smooth running. Okay, then different horsepower ratings are there. Okay, so what are the important horsepower ratings? Okay, not all the engines power pull the train. Okay, on average 82% power is left to pull the train. So another 18% power will be dissipated. Okay, that will be 82% power will be utilized. The rest of the power will be lost. Okay, so 82% power horsepower will be left for the hauling of the train. So what are the most important thing? Gross HP generated by the diesel engine, then some of the power of the axle wheels, okay, auxiliaries, okay, auxiliaries like cooling fan, motor, blowers, locomotive control or air brake compressor that will be used. Then locomotive HP available to the torque into RPM, okay, then that additional energy will be torque into RPM. So initially you are given the energy, so some of the energy will be used for the relay, cooling fan, motor blowers, okay, the most important issues it is required, okay. Then rest of the power will be come to the for the traction purpose, okay, torque into RPM. So that traction power is loss in generator, means alternator or the rectifier bank of capacitor, okay. So that means converting the crankshaft power efficiency, lot of machineries are there, okay. So that magnetics loss will be there due to hysteresis and eddy current loss. Crankshaft means it is used for the compression. In the compression you are using means pantograph uplifting and downlifting, okay. So both of the cases you have to use some that is called baby compressor, okay. So that baby compressor is used. Normal compressor is directly associated with the brake. Another compressor is additional compressor that is known as baby compressor. Why it is called baby compressor? It's look small compared to your normal compressor, okay, for the braking system. So that is useful for the upliftment of the pantograph, okay. So some of the energy will be lost over there to the motor purpose. Then rest of the energy will be electrical power to motor, means volt into ampere. So it is your mechanical energy. So total gross energy, then it is coming mechanical energy excluding the loss of mechanical loss. Then that mechanical energy is converted to the electrical energy, okay. If mechanical energy is converted to the electrical energy, definitely there is some losses. So that losses in your magnetics loss, okay. Then electrical energy is there, then traction motor losses, then gear frictions, then again mechanical. Basically motor is means energy conversion device, and it's a motor means electrical to mechanical again, okay. So definitely the traction motor losses will be there due to the friction and heating effect. Lot of effects will be there. HP at the rail, that tractive effort at the wheel into wheel rim and that speed, okay. Then the power move to the lift of the acceleration weight of the locomotive itself, varies of the speed, grade, curvature, okay. Loco or train weight ratio, that means how much load is there, and the total overall weight of the train, okay. Then drawing the HP and drawing the pull speed, okay. Then power to the whole train of 82%, so you will get that 82% power. Finally you will obtain, that's why 18% of that, also known as that ATC loss, like that, okay. So that 18% of energy will be dissipated, okay, from gross to means efficiency, okay, gross to utilization of the energy, okay. So then here you can see that the diesel electric locomotives, okay. So the diesel electric locomotive, what happened? So end of the day, what is your motivations, okay. So your motivation is to your main motivation, what is your main motivation? Your motivation is to move the prime mover, okay. So sorry, to convert the electrical energy to mechanical energy, okay. Basically you are using that so basically you are using that motor, not traction motor. What is the purpose of the traction motor? Purpose of the traction motor to overcome the means frictional effect, okay. So or movement of the movement of the wheel, okay. So that is your primary agenda, okay. So initially you are using the diesel engine. So diesel is the combustion, okay. So combustion means chemical to mechanical, okay. Basically that electrical energy should be required, okay. That will be coming from the combustion of the diesel. So from the electrical energy you are getting, so you are moving the prime mover, okay. So turbocharger, electronic fuel injections, okay. That all are the important features for the diesel electric locomotive. Both are there, okay. Alternator, then generator, fan, batteries, and AC/DC traction motor. So diesel is there for the generations, okay. You know that one, chemical conversion. So when when any occasions is arranged in our house, then what we are using, so we are using silent generator. In the very beginning means after 5 years 10 years back, we are hiring the we are normally we were hiring the generator. Okay, then we put some kerosene or diesel to the generator, then we just make it start, then chemical energy is then it will be combust. Okay, then combustion of that diesel, then that combustion energy is responsible for the movement of the prime mover of that generator. Okay, then prime mover is rotating. Okay, sorry, prime mover is means shaft is rotating, and that electrical means rotating in the pre-filled that means there is a conductor will be there. If the magnets, that shaft is directly connected with the magnets, okay, means it can cause for the generations of the electricity. The same fundamental thing is used here, that generations is there due to the generation is coming from that generator. Okay, then that generator is responsible for driving the motor as well as supply the internal electricity of the locomotive and the bogies connected with the locomotive. Okay, that's the basic fundamental thing. So here some diagram is there. Okay, for that inter process means diesel electric locomotive. Okay, so it is locomotive principal components. What are the most important components are there that you can observe, that that means location of the principal components. So what are the important things? So diesel engine. So here I just show you that diesel engine initially. This is your diesel engine. Then different things are there like change air filter, then main alternator, it's your alternator. Okay, so it's your wheel, you know that it's your wheels are there. Okay, then air instant filters. Okay, so different parts are there. Okay, and details discussions, and that wheels are there means you know that wheels locations. Okay, actually it will be look like that. Then you know the radiator means heat radiators are there. Okay, so you know that if the then the battery packs are also be there. Okay, for the charging stations. Okay, fuel tank, that means diesel will be given here. Okay, that's why that fuel tank is important. So if you if you travel with the train and means waiting in the stations. Okay, if the diesel locomotive is passing through you, so you can feel some heat is coming from that locomotive. Okay, so that heat means that heat sink is there. Okay, so it's radiator fans everything, na? So heat radiators are there, that is responsible for heat sink. So then rectifier means you know that AC generation will be there. Then the batteries, I am telling you, na, battery, these are all of the battery pack. So battery pack may responsible for what, that emergency few ways of last class I am telling about you the frequency mismatch. There is sometimes what happen, options of the frequency mismatch. So in that case you have to stop that locomotive at that zone. So who will take responsible, the battery will take responsible for driving that portions. Okay, so who will charging, the battery will be charging by that charging stations. Okay, so charging station means power electronics converter, and the rating also very high. Basically it is 25 kV in your overhead lines are in 25 kV. Okay, so definitely it should be reduced with this value. Okay, so that means your charging station power electronics converter will be designed in such a manner. Okay, if it is not high end, so it will not able to control. Okay, so that all are the very important features, and the diagram you can see it is air compressor, sandbox, I am telling you, na, sandbox, sander is there. Okay, so most of the important then signals, some of the signals also be required. Okay, so control signals means when you know, I think it is upper side. Okay, so upper side of here. So it is your air respirators. Okay, so then diesel engines. Okay, that is top view, it is side view. Okay, cross sectional side view, and it is total side view. Three views are there. Okay, so signal, when it will be passing through the signal, so definitely it should provide, means that signal automatically will be read. Okay, so you know that diagrams. Then here you can see what are the radial tracks. So you know that what are the different types of tracks. So locomotives is rotating. Okay, so normally it is a conventional track. Okay, in conventional track, so these wheels are there, it is holding. But in radial track, what happened? That wheel, that means all are in 90-degree, means sorry, parallel in nature. Okay, but here you know that there is some angle, that is radial arrangement. So that radial arrangement, you know, that is the basement. Okay, basement of your locomotive. Okay, so after that, so some springs are there, everything. Okay, not like only spring, lot of things are there. Then the coach, then the body of that train bogie or the locomotive body will be established just above this part. Okay, so it is your wheel. Okay, so wheels are there. Then three sets of wheel, one, two, three sets of wheel will be there, and you know the traction motors also been connected in between the wheel. Just below of this one, the traction motor is there. So one traction motor is driving the first wheel, another traction motor will be driving the next wheel. Okay, like that. Okay, so that's the process. Okay, so how it will be look like that locomotive control unit. So you know that it is inside of that control units. I am telling you, a lot of meter monitoring units are there. Okay, then emergency bay, then backside of this driver. Okay, that backside also be lot of monitoring units are there. Not like only these few panels. Okay, lot of monitoring unit also be there just backside of the driver. Okay, so minimum levels but connected in the circuit. Okay, so fault conditions and normal condition, two things you need to study. Okay, if the fault is there, definitely the fault terminal light will be enabled, means you can recognize that at that means you can understand that fault has occurred. That's why the light is enable. Okay, then microprocessor based control. Previously that all the relays are in a very manually driven relay. There is no application of microprocessor. Microcontroller means right now microprocessors are also very next generation, means high, means latest generation microprocessor are using like DSP processor, then microcontroller based unit, controlling unit for the relay. Okay, and the display skin, another important issue, the display skin. So the speakers also be there. Okay, for emergency announcement to the inside of the train. So the speaker display screen all are there. Right now the LED lighting also been important. Basically technology has changed. Okay, means upgraded technology is available. Okay, so day by day what happened, the generation of the technology is changing, so you have to cope up with that next generation technology. If we are not able to cope up with the next generation technology, then what happened, then system automatically extend. Okay, the system automatically extended. Okay, so that's why you should keep focus about all those applications and the modifications and the latest issues and latest technology of your system. Okay, so in my first class I told you na, so number of axle. Okay, that was you can see it is 6 axle. So 6 axle means one, two, three pairs of your front wheel, means in front side 6 wheels are there. So 6 wheels will be holded by the 3 shaft from front side, and back side another 3. So that's why it is 6 axle. Okay, that's why it is known as 6 axle. Approximated 390,000 pounds it can be moved. So you know that relation between the pounds and kilogram. Okay, you can give a Google search the conversion, you directly get it from there. Okay, so how much kilogram is there, you can understand. Then you know that next one is your 4 axle. Okay, so here you can see only 2 pair. Okay, so only 2 pairs of your front wheel and another 2 for your second wheel. So that is 4 axles. So if the axle is less, definitely weight also been less. In first it was 390,000 pounds. Now it is 260,000 pounds. Okay, so changing of the axle, the rating also will change. Then multiple unit arrangement. Okay, so multiple unit arrangement means that I am telling you. So only locomotive is working. It doesn't make sense. Okay, it does not make sense. Why? If there is not applicable for, if the locomotive is not applicable for good carriers or the passenger carrier, so it does not have any sex in sense, na? So that's why distributed power is important. Distributed power means you know that for one locomotive can take responsible for another few bogies. If you traveled with any AC train, total fully AC train, so you can see end of that coach having one car that is called generator car, like Rajdhani, the Duronto. If you are traveling there or you are waiting in a station and it is passing in front of you, so you can see that is generator fan. Okay, so why it is important? Means the purpose of the generator van is means it can be connected with the locomotive main portions. But what happened right now? The again the concept of the distributed parameter, not like the lump parameter. Okay, so lump means all the thrust will be coming to the single area. Okay, so that's why it will be distributed. So generations is done and also maintaining the balance of the system. Okay, so that's why generator van is connected backside of your system, but it will be connected through the wire individual bogies and coaches and the motor coaches. Okay, that is called the distributed power. And mid train or the rear end. Mid train and rear end means you know that electric multiple units. Okay, it having four or something, sometimes three. 9 coaches means three. For one motor coach can take responsibilities for another two coaches. Okay, so itself and another two coaches. So one motor coach is important for three coaches, means can take care about the three coaches. So if the three motor coaches are there, so it can take care about in 9 coaches in Indian Railway. Okay, for the EMU, electric multiple unit, or the MEMU. Okay, so but DMU means diesel multiple unit. Right now it is obsoleted. Okay, so but in locomotive, what happened? Locomotive, that facilities are not there. Basically only front side, only front side the locomotive will be there. Otherwise the back side means rear end. Okay, only two options are there. But in that EMU means urban and suburban travel, so there are 3 or 4. If it is 12 coaches bogie, then 3 into 4 means 12. Okay, so 4 motor coaches will be there. Okay, 4 into 3 actually 12. Okay, so 4 motor coaches can take responsibility. Okay, so that the motivations for the mid train and the rear end. So in that case, mid portions, the motor coach is there, and front and rear. Front is mandatory and rear, so all are there. Okay, so it is distributed. It also means distributed. Okay. Slug and mates. So what are the importance? In the previous cases, you know that there is no prime mover. Means what happened? No prime mover store excess power and provide the weight and tractive effort. So what happened? In these cases, you are using directly chemical energy to movement of the traction motor. Okay, sorry, movement of the means stroke engine. You can think like that. The diesel engines are there, that can energy is generated. That energy is directly you are using, that energy passing through the piston, and that piston is traveling is responsible for movement of that wheels. Okay, that wheels are there, that is directly movement. So there is a some benefits are there as well as some disadvantages are there. Okay, what is your advantage? What is your advantage? The basic advantage is that energy is comparatively less. Okay, so loss is comparatively less. Basically, how much conversion will be there? So energy losses also be enhanced. Okay, but in electrical case, means electrical locomotive, then what happened, what we are going for electrical motor locomotive, so there is, we are not using the diesel. Okay, directly electricity is taken, and that electricity coming from the traction substation. Okay, so directly electric motors are there, and motor is responsible for conversion of electrical energy to mechanical energy. That mechanical energy is responsible for the tractive effort, means the movement of the wheel. Okay, so what is the advantages? So it is noiseless, pollutionless. Okay, so as well as very sophisticated controlling method. But the mechanical control means definitely it's a huge sound loss, means a huge sound pollutions, corrosion, then pollution, then other losses also been there. But more or less all having some advantages but disadvantages. But in electrical locomotive, you can see the advantages are more compared to your disadvantages. That's why currently all types of locomotives are obsoleted. Only electrical locomotives are involved. Okay, so that kinds of observation you can see. Advantages of the traction system. So what are the advantages? So multiple unit traction system, that I am telling you. EMU means electrical multiple unit, or DMU, diesel multiple unit. Then driving force, so you are using different driving forces. Okay, like from multiple units. Okay, so there you know that this different multiple unit means 3 or 4 motor coaches are there in EME, so that can give you different driving force individually. So different, that means 4 or 3 multiple driving force you can achieve or you can observe. So EMU is normally used for suburban railway transport. Okay, but the main problem is that you are using rheostatic braking or the dynamic braking, so no regenerative braking, only plugging sometimes you are using for backward movement of the train. Okay, but most of the cases you are rheostatic braking. Basically regenerative braking only possible for the long line travel. Otherwise regeneration means some times are required. Okay, so if that time is not sufficient for suburban or urban travel, basically 5 kilometers, you know that minimum 5 kilometer, maximum 10 kilometers distance may be covered in between two stations. Okay, so taking some time, okay, for achieving the top speed, okay, from the 0 speed to top speed, so taking some time, so you can see how much time is required to reach the maximum value. Okay, then you know that half of the way you have covered, so rest of the portion make the constant speed, again stop. But there is no options for the regenerative braking for our local train connectivity. Okay, so that's why their engines also been different. Okay, they are the transformer, that auto transformer also been different configurations for EMU. Okay, for DMU, sorry, for mainline traction, the transformer configuration also been different. Means tap changers are in primary side, some cases stack changer, mean tap changes in the secondary side. Okay, so in case of local train, means EMU, the tap changes normally I think it is in secondary side. Okay, basically what happened, secondary side tap changer means secondary side voltage is less, so power is making constant, means voltage is less means current is high, so huge problem of the leakage current, means huge current will be flow through the system, so there is a leaking of the current, means you know that flashing effect will also be there, but it is much more convenient for that case. So you are using that secondary, the tap changers are installed in the secondary side of that EMU. Okay, so advanced technology means magnetic levitations used for the ultra high speed train. Okay, so you know that in Germany and Japan. Okay, so one case is attraction type of magnetic levitation, another one is repulsion type of magnetic levitation. So both are using. Okay, so as for the application right now, you know that I just forgetting the name, hyper tube, then a lot of names are coming now for the ultra fast applications, okay, of the tractions. In that case, two important things are there. There is be no wheel means no frictional force directly, and that's why reducing of the frictional force means that high speed operations may be achieved. Okay, electric tractions that economical, easy, and safe. Most important is the safety. Safety means when you are designing any of the system, so how much safety you can provide, factor of safety. Okay, safety factor, how much safety factor is there, so that will be tested in any standard lab. Okay, then you will get the approval for public transportation. Okay, so economical, why it is economical? Basically you are using electrical appliances are comparatively economical, and the controlling of the electrical appliances are comparatively easy and the cost efficient. Okay, that means most of the cases you are using solid state devices, and solid state devices means it will take huge currents, maybe huge voltage, but semiconductors are associated with it, means the energy less comparatively, means significantly less with your mechanical system. Okay, that kinds of advantages you can see. Another two advantages, the locomotions in which the driving force is obtained from the electric motor is called the electric traction system. Okay, so normally two types of traction system, one is electric traction system, another one is mechanical traction system. Okay, so mechanical energy is used for the tractions, means movement, means piston you are using for the initial days. For initial days we are using for diesel, then before that steam turbine, means steam we are using for the traction purpose in the form of steam or chemical energy. Okay, for the movement of the wheel. Okay, so piston we are using, 2 stroke, 4 stroke, then 6 stroke, like that. So there are the various system for the electric tractions existing, such electric train, trolley buses, diesel electric vehicle, gas turbine electric vehicles. Okay, these all are the examples of the various system of electric tractions. Okay, so I think all of you are able to understand the what is the importance of the different sources of that traction, then braking method. Okay, what are the important features? Okay, so if you have faced any kinds of difficulties, you can ask me, and you can write me in the chat box, so I can give the answer. Okay, so if you have doubts, so I can again today just complete my session here. Okay, so if you have any doubts, so I can discuss on it. Okay, so if you have any doubt, you can ask me. You can also write it in the chat box.
Sir, for the reference,
Yes.
sir,
Shakti.
yes, sir. Sir, for reference, which book we should follow? Sir, the
Actually,
books you showed,
actually,
I
you
am
can.
not able to.
Actually, in my first class, I discussed about different names of the books, but that portion I have telling you, I am not following any book. Okay, that is my own idea, so I am sharing with the slides. Okay, so you can follow some. I mentioned some utilization book by Narosa Publications. Then some books from CL Wada books also important. Also, you can follow different books are already available.
That book's soft copy I am unable to get. It's not in internet.
Uh, Actually, soft copy, I can provide you the slide. Okay, so or you can also follow the video. The slides are already there, but some numerical problem. I think you can follow other books also. That utilization, it doesn't means you are only follow those name I have given. It doesn't like that. You can follow other books also, means some foreign author books, those soft copies are available. Okay, you can also practice some numerical problem of that. So pattern of the numerical will be same. Okay, but numeric digit may be different, but pattern is same. So you can follow any of the soft copy of the book. If I get some book, so definitely I'll upload it. Okay, but you can also
Sir,
search it. Okay, so anybody can get any soft copy of the book. They can post it in this group. Okay, means they can upload it in this book. No problem. So all of you get that one. Okay. Tell me.
sir, these slides can you send?
Definitely. After completions of those things, I will share with the slides. No problem. But my suggestions, okay. But my suggestions, in my last year, I also told you that I am always following. Means if you follow any of the standard book, okay, and keep your class note ready as per my the lecture guideline. But before the exam, I will share the slide. But day by day, if you follow my classes, if you follow my lecture, so you can also prepare your own material. Okay, so you should not total depends on my slide. I will share it, but I am also believe by the self study. Okay, means if you prepare your notes with gathering with two three books, so that will be much more helpful from your side, na? So if I give you some slides, so you can follow the slide, means only follow only the as a research material, you are following only the slide. So slide content very brief, or slide content very brief idea, very significant points are there, but thorough discussion, thorough ideas you can get only for studying a books. That's why my suggestions do not totally depends on the slides. Okay, you should follow any of the standard books. That will be much more convenient from your end. Okay, whatever books are available in the online, you can follow it, no problem. But day to day you should submit the material, means class note. So last Sunday there was one deadline to submit the class note, but I didn't get any response from your side. Okay, so but how much I have completed, how much I have covered in my last week, maybe you should not submit it by today. So take this month, how much I can cover by December. Okay, so you should submit it in my in the first week of your January. Okay, so first week of your January means I can completed my classes, means next Thursday or Friday. I just complete my, means you can submit it in next week. Next means by this weekend, means by this Sunday. Sunday is your third, I think so, 3rd January. You can submit all those class note from introduction to up to I have covered by this week. Means by this Friday you should submit it coming Sunday midnight. Okay, by midnight you can submit it. So you see here, Sankalp will share that link. Okay, means Google Form link. You should take your means take the snap. Okay, snap means PDF scan. Okay, you can use Adobe Scanner. Okay, so online PDF scanner you can use. Then make it PDF of your class note. Then you have to compress it. Okay, within few KB. Then you have to upload that compressed material. Okay, to the Google Form link will be provided by your CR Sankalpa. Okay, so that is my suggestions. I think all of you will able to understand my idea. Okay, so thank you. Today I just stop my session.